we completed up to question number 3, right? Exercise 8.1 we started. So the third question we have done, show that if the diagonals of a quadrilateral bisect each other, then it is a Roman.
Excuse me, ma'am.
Yes.
Actually, 8.1, 8.3, and 8.5 are omitted for us.
8.1.
And 2, 3, and 5.
Just 1 minute, 1 minute. But there are only 8.2 up in NCRT. There are only 8.1 and 8.2. Yes, Ziba?
Yes, ma'am. Actually, I'm checking it.
Yeah, let me also check the syllabus. Just 1 minute.
Yes, ma'am, you're correct. But actually, in the index page, it was there like 8.7 till.
Okay, just 1 minute. Opening it. See, this is the syllabus which I am having, and it is downloaded from NCRT website, the CBSE website. So 2022 to 23, class 9th. Now the chapter quadrilateral, right? So
Yes.
these theorems are there in the syllabus. The diagonals divide a parallelogram into two congruent triangles. We have done. Okay. Second, okay, its proof will come in the exam. So you can mark it important because in the syllabus it's written. I'll also send you that.
Yes.
Okay. Now
Okay.
second. Okay. Now second. In a parallelogram, opposite sides are equal and converse. So we have done it. Third, in a parallelogram, opposite side angles are equal and converse. Okay, done. Fourth, a quadrilateral is a parallelogram if a pair of its opposite side is parallel and equal. This theorem is also included. We have done it. Fifth one, the diagonals bisect each other and the converse of it, right? And sixth one, in a triangle, the line segment joining the midpoints. So basically, midpoint theorem is exercise 8.2. So according to this syllabus, both are in the like 8.1 and 8.2, both you have to do.
Okay. Actually, in my index, it's there like uh means it's there till like 8.7. So I thought I
Okay, which book you
think
are
I'm good.
referring to?
The same NCRT book. Then
Um,
actually, when I checked in lessons,
mm.
the chapter when I opened, it's like till 8.2 only.
Okay, so from where have you downloaded that book? From NCRT website?
No, ma'am, I have the textbook only.
Can you send me picture?
Yeah, I will.
Because I have the PDF version of the book which I have downloaded from NCRT website, and it has only exercise 8.1 and 8.2. That's it.
Yes, ma'am.
Just send me the picture of the book. Let me have a look which book you are having. Jesslyn, are you also having a similar problem? Please unmute yourself, Jesslyn.
Then can you hear me now?
Yes, I can.
I don't have any problem like that, ma'am.
So 8.1, 8.2 are there in your book, right?
Yes, ma'am.
So Zeba, you have to send me the picture of the book. I think I don't know which book you are having. Let me just check it, okay?
Can you please check it?
Yes, yes, let me just see. Introduction. See, Zeba, can you just send me the front page of your book? The cover page of your book, please. No, no, this is exercise. Yeah, this is right. Just 1 minute. Let me match with this. 9. Yeah, okay. Okay, so okay, now I got the problem that you are having is. Yeah, book is fine, Zeba. See, these are basically the sections in the, these are not exercises, 8.1, 8.2. These are basically the sections, okay? So the first is omitted. For example, 8.2. Now try to understand. What is written here? Angle sum property. Yes, Zeba? Of a quadrilateral. So that we know that sum of all the angles of a quadrilateral is, for example, this is x, y, w, and whatever u. So we know that x plus y plus w plus u is equal to 360 degree that we have learned. Is that clear? Now, in your exercise 8.1, the first question which we have done, where the quadrilateral, the angles are given in the ratio, you have to find all the angles. So we can say that this particular question will not come because it is based upon this angle sum property. I hope you understand now, right? Yes, Zeba? Okay, anyway, let us complete the exercise now. Now see this question number 4, please, both of you. Show that the diagonals of a square are equal and bisect each other at right angle. So you have a square. Now see here, show that the diagonals of a square, right? So first of all, what is given to you? If I call it A, B, C, and D. So it's a square. This is given. That A, B, C, D is a square. Are equal. So you have to show that the diagonals are equal. That means to show AC is equal to BD, right? First thing. But diagonals are equal and bisect each other. Bisect means they divide each other into two equal parts. So if this is O, so we have to also show that AO is equal to OC. Is that correct? And third thing, at right angle. So we also have to show that one of the angle, for example, this angle, if I name angle AOB. So angle AOB, and in fact all the angles, angle BOC, angle COD, and angle DOA. So they all have to be equal to 90 degree. This you have to show. Understood?
Yes, ma'am.
Okay. So let us do the proof. So first thing we try to show AC is equal to BD. The first thing that the diagonals are equal. So that we can do if we show two of the triangles congruent. Now see AC, right? Now AC is part of the triangle ABC. Can you see that? Yes? Yes, Zeba Jaslin, right? I'm taking the triangle ABC, right? Okay. Now I want BD. So that means I have to take the triangle BCD. Is that okay?
Okay, ma'am.
Yeah, ABC and DCB or BCD. Basically, right side, upper triangle and lower triangle I'm taking. Okay. Let us prove them congruent, and by CPCT we can say AC is equal to BD. Right. Now who will tell me what I can do here? Tell me one thing I can write here to show congruency. So basically I'm taking like one triangle like this, right? And the other triangle like this. This I'm taking. Come on, I always say, yeah, say.
ABC is 90 degree and if BCD is also 90 degree
Why?
because it's a square.
Exactly. So use the given condition, right? It's a square, so the angles are 90 degree. Very good. So I can say that angle ABC and equal to angle DCB is equal to 90 degrees. Right? You can write all angles of a square are 90 degree. And what else? What are the other features of a square? Angles are 90 and what about sides?
All sides are equal.
Sides are equal. So which side you can take equal here?
AB.
AB equal to, come on, AB equal to CD, isn't it? Sides of square are equal, right? This side AB and CD are equal because they are sides of square. And also one side is common. BC is equal to BC, which is common, right?
Yes, ma'am.
So which criteria does it become? There are two sides and one angle. So SAS, right? By SAS criteria, triangle ABC is congruent to triangle BCD. And by CPCT, you can say that the side AC is equal to BD. Is that understood so far?
Yes, ma'am.
All right. So the first thing we have shown that the diagonals are equal. Now we try to show that the diagonals bisect each other. So this condition we have shown. Now we will show this, that AO is equal to OC, and yeah, the other one also I have not written. BO is equal to OD. So this we have to show now. So you can write a line, and now we show that diagonals bisect each other. I mean, just for your understanding, I'm writing. So I'm just dividing the question into parts, right? Okay. Now, because I have to take diagonals, so what will I do is, now that was my square, just roughly I'm drawing. So A, B, and C and D, right? These are the diagonals. Now I have to show that the diagonals are equal. So I'll take triangles where diagonal is coming, right? So if I take this lower triangle, I mean this one, so you can see AO and OB are sides of it, right? And then I take this triangle. So OD and CO are sides of this triangle. So basically, you will get some relationship between the parts of a diagonal. Is that correct? This triangle and this triangle I'm taking. You can draw a separate figure for this, like this, and mark your triangles. So in triangle AOB and triangle COD, I'm taking now. Let us prove them congruent. Who will tell me first thing which I can write? Okay, which side is equal here? Hmm, very good. AB is equal to BC, that's right. And see, I'm taking triangles, right? So only one side you can write, which is AB is equal to CD. The other sides you have to show. So forget about side now. Now come to angles. Which angle you can write here equal? So at least two angles you need. Understand? See, one side already got. Now you cannot take any other side. So forget about sides, right? Now think of angles. So at least two angles you have to show that they are equal. Is that clear? Because we need three things for congruency. Understand? Okay. Now let us look at the angles one by one. Okay. Now if I name this angle, let's say this is angle 1 and this is angle 2. Do you think they are equal?
Yes, ma'am.
Why? Which property? How many times I told you? If you have an x, right? What is these angles called? Vertically opposite angles, isn't it? Right? So angle 1 is equal to angle 2. Okay. Now one more angle you need. So either this one or this one. So if I now try to understand what is happening here. This is already a square, right? Square means it's a parallelogram. That means the opposite sides are parallel. Understand? Square is a parallelogram. So the opposite sides are parallel. So let's say this is my side AB and this is my side CD. And you can think of any transversal. Let's say this is your transversal. So this angle is going to be equal to this angle, isn't it? What kind of angle they are? alternate interior angle, right? See, you have to use the properties of parallelogram now. When it is written that it is a square, right? Now that is an important thing which is given. That means all the properties of a square you have to use in this question. Is that clear? Square is a parallelogram. Use the theorems of parallelogram here. Properties of parallelogram. Now angle 3 is equal to angle 4. Why alternate? No, you write first of all that AB is parallel to CD and therefore alternate interior angles are equal. Write complete so that you remember. Is that okay? Now my triangles are congruent, right? So by which property? Two angles and one side. So ASA, right? Or AAS. Because in continuation you have two angles, right? So A, and then S, AAS. Triangle AOB is congruent to triangle COD. And by CPCT, the other two sides are equal, right? So by CPCT, we can say, so you have to take like this because angle 3 is on this side and angle 4 is on this side, understand? So you have to take it like if you are taking AO, so it will be equal to OC, getting it? Okay. And then this is O, right? And then OB is equal to OD. So what does it imply? Hence, the diagonals bisect each other. So this we have proved. Here also, like you can write a concluding line, AC is equal to BD. So you can say hence the diagonals are equal. I mean, it's not necessary, but you can. So equal and bisect we have shown. Now we have to show that they bisect at 90-degree angle. Third thing we have to show. I hope you have written up till here.
Yes, ma'am.
Okay. Now let us move to the third part. So again, I'm drawing a figure. This is a square, right? A, B, C, D, and O. So you also have to draw a different figure, otherwise it's easy to mark in different figures, but naming has to be same, A, B, C, D in the same order. Okay. One figure also you can draw, but if you are thinking it's getting too messed up, you can draw it again separately. No issue in that. So let us try to show that one of the angle, let's say this is 90-degree. See, now look here. This is an X, correct? If I show that this angle, let's say this is 1. If angle 1 is 90, obviously angle 2 will be 90. Is that clear? Vertically opposite, right? Okay. Now if angle 2 is 90, then 2 plus 3 is a linear pair, so 3 will also be 90. And if 3 is 90, then 3 and 4 both are vertically opposite, so 4 will also be 90. So no need to show all the angles, just show one angle to be 90 degree. Other 3 will also be 90. I hope it's clear. Yeah, so one of them we will try to show. This time I take this triangle and this triangle. Let's take this. First of all, let's try to prove them congruent. So in triangle AOB and triangle COP, right? So what else do I have now? So now I can say that OA is equal to OC. I have just proved, right? Okay. And I can see OB common, right? It's a common side. OB. Okay. And also third side is also equal here. AB is equal to CB because sides of square. Is that clear?
Yes, ma'am.
Yeah. See, when you try to show congruency, you have to do only two things. First, look at all the three sides, then look at all the three angles. That's it. Here, all the three sides are coming out to be equal. So, by SSS criteria, triangle AOB is congruent to triangle COP, right? Now, why I'm doing this? Let's say this is my angle 1 and this is my angle 2. I don't know if it is 90, just mark it like this, angle 1 and angle 2. So by CPCT, now I can say that angle 1 is equal to angle 2. Is that clear?
Yes, ma'am.
So this result I have got. You can mark it something, equation number 1. Now we know they form a linear pair, right? So angle 1 plus angle 2 is equal to 180 degree. It is a linear pair. So both
Yes,
are
ma'am.
equal because I need 1. So I'll write angle 1 and I'll replace also angle 1 is equal to 180 degree. So twice of angle 1 is equal to 180 degree. So angle 1 will be 90 degree. Or you can say angle AOB is equal to 90 degree. Right?
Mm.
So therefore you can say hence AC and BD, which are the diagonals, right? AC and BD bisect at 90 degree. So now the question is complete. See, the question is not tough, right? You just have to remember the concepts. And it's a good question. Like you can divide this into 3 parts and solve it. Written?
Yes, ma'am.
Next question. Now this is just the inverse question, like opposite question you can say. Show that if the diagonals of a quadrilateral are equal and bisect each other at right angles, then it is a square. So all the three things which we have just proved, they are given now and you have to show that it is a square. Is that clear? Yes, is that clear?
Yes.
Okay. So let us draw a square first of all. And its diagonals. Right. Again, I'm naming in the same way A, B, C, D, and O. Right. Now look at the difference here. Now what is given? Diagonals of a quadrilateral are equal, right? So first thing is given that AC is equal to BD. All the results of the previous question are now the given conditions. And they bisect each other. Second, so that means it is given that AO is OA is equal to OC, right? And OD is equal to OB. Is that clear? Okay. And also they bisect at right angle. So if I just name them angle 1, angle 2, angle 3, and angle 4. So angle 1, angle 2, angle 3, and angle 4, they all are equal to 90 degrees. This is given. Now you have to show that ABCD. Now what is ABCD? So right now we are calling it a quadrilateral, right? We don't know it's a parallelogram or not. It's written a quadrilateral in the question. Quadrilateral ABCD is a square. You have to show this. Right? Now tell me, Zeba, I told you if you want to show a quadrilateral to be a square, what are the three things you have to show? So what exactly you have to show here? Jaslyn, please unmute yourself.
Can you hear me?
Yes, I can.
All sides are equal.
Hmm.
All angles are equal.
Okay. All angles are equal, but how much?
The sum of all angles are is
No, no,
360.
no, no, no. What is the measure of one angle of a square?
90 degree.
90 degree. I told you have to show only one angle to be 90. Just forget about all the other. They will come out to be 90. I told you yesterday, right? So only one corner angle we show 90 degree. That's it. Okay.
Okay, ma'am.
See here, try to understand if it is a square, right? Now, first of all, what is Zeba? Can you hear me now?
Yes, ma'am. Can hear you.
S- Try to understand if you want to show something to be a square, you have to show three things. I also told you yesterday. See, first of all, a square is a parallelogram, isn't it? So, and in the question, it is written only quadrilateral. So, the first step, we will show that it is a parallelogram. Understand?
Yes, ma'am.
Okay, so parallelogram means opposite sides are parallel, right? Parallel
Yes, ma'am.
or we can say equal, right? Opposite sides are equal. First thing we will show. And parallel, you can say it's easy to understand. First of all, show that it's a parallelogram. That means opposite sides are equal. Now, second thing, so opposite sides can be equal in a rectangle also, right? It can be equal in a rhombus also. So how to differentiate? So all the sides are equal. So this also you have to show that all sides are equal. Is that understood? In a square. Is that clear?
Yes, ma'am.
See, these opposite sides are parallel. Now this condition is satisfied by square also, by rectangle also, by rhombus also, right? So for a square, you have to show that all sides are equal, right? Now, all sides are equal in a square also, in a rhombus also. So how to differentiate? We show that one of the angle is 90 degree. That's the third thing you have to show. I hope it's clear now.
Yes, ma'am.
Yeah. So please remember when you have to show the square, you have to show the maximum number of things, right? Three things you have to show. It's a parallelogram. Opposite sides are equal. One of the angle 90 degree. All right. Now let us do the proof here. Right. So to prove ABCD is a square, I think you should elaborate this to show after writing ABCD is a square, so you can write for your understanding. So we need to show three things. This will help you to remember. Right? First thing we have to show that ABCD is a parallelogram. Right? This we will show. Second, to make it a square, we have to show all sides are equal. Right? And the third thing you have to show that one corner angle is 90 degree. Please write, this is important. Okay? You can write in exam also like this 1, 2, 3. So you basically show three things to show it's a square. Written? Yes, have you written?
Yes, ma'am.
Okay. So first of all, let us uh, try to show that the opposite sides are equal. Let me take this triangle and let's prove them congruent so that we can say AB is equal to BC by CPCT. Is that clear?
Yes, ma'am.
Okay. So in triangle AOB and triangle POC. Quickly, who will tell me what can I write here? Look at the given conditions very quickly. So everything is already given that the diagonals are they bisect each other. So OA is equal to OC given, correct? Okay, one side OB is equal to OB, that is common, right? And third thing, already given that all the angles are 90 degree. So angle 1 yeah is equal to 2, which is 90 degree each, which is also given, right? So I have got three things. So they are congruent. Which criteria? One angle you are taking and then two sides. So SAS, right? Side, angle, side. This way you are taking. So triangle AOB is congruent to triangle BOC, right? And by CPCT, you can say that the side AB is equal to BC. Is that clear?
Yes, ma'am.
Okay, so AB is equal to BC. You can mark it some, let's say this is my result number 1, right? Now, if similarly, I take the other two triangles, if I choose this triangle and this triangle, so from here, I'll get AD is equal to CD. Is that okay?
Yes, ma'am.
Okay. So similarly, you can say, similarly, if you take the other two, that triangle AOD will be congruent to triangle COD, right? And this will give you AD is equal to CD, right? Equation number 2. Is that clear?
Yes, ma'am.
Now, from here, you see, you cannot establish the relation. Now, what is coming out? AB is equal to BC. and AD is equal to CD. So you cannot say that all the sides are equal. Just two sides are coming out to be equal, right? See,
Yes, ma'am.
okay, just 1 minute. My screen is hanged. Yeah, just 1 minute. Is my screen visible?
No, ma'am.
Yeah, okay, some network issue. Just wait a while. Yeah, is my wide mode visible? Sorry, my
Yes,
OneNote
ma'am.
is
Yes, ma'am.
facing. Okay, so that OneNote is not responding. Anyway, so I'll not start from again. Just there's a square which I'm having. A, B, and C, D, right? These are the diagonals. Oh, so basically, when I'm taking this triangle and this triangle, so I'm getting AB is equal to BC. Is that clear? Yeah. Now, when I'm taking this triangle and this triangle, so I'm getting AD is equal to CD, right? Now, from here, I cannot conclude that all the four sides are equal. I can just say AB is equal to BC and AD is equal to CD. So I have to take connecting triangles. So if I take this triangle and this triangle, so what will I get? Same way I can show them congruent. So if they are congruent, so I'll get BC is equal to CD. Is that clear? Yes?
Yes,
Yeah. Now, if you relate one by one, this is your equation number 1, equation number 2, and equation number 3. Now try to write. So first thing I'm writing AB is equal to BC, equation number 1. Now see BC is equal to what? So from 3 you can see BC is equal to CD, right? So you can write CD. Now from second you can see CD is equal to AD. So you can write AD. So now you can say that all the four sides are equal. Is that understood? Yeah, okay, it's back now. Just 1 minute. Mm, I hope it's understood, right? All right. So this was my equation number 2. And also I can take the triangle, as I said, the connecting triangle. So this one and this one I'm taking, right? So triangle BOC will be congruent to triangle COD. And this is going to give me BC is equal to CD. This is my equation number 3. Is that okay? Now, if you combine, so from equation 1, 2, and 3. Now, just so you understand how to relate all the three equations. So first of all, write the first one. AB is equal to BC, right? Now BC is coming in equation number 3. So BC is equal to CD. So you can write equal to CD. CD is coming equation number 2, which is equal to AD. So you can write AD. Is that understood?
Yes, ma'am.
Okay. Hmm. So now what you have to show the first thing that it is a parallelogram, right? So in quadrilateral A, B, C, D. Now what is coming out? What should happen in a parallelogram? First of all, tell me any parallelogram. Opposite sides have to be parallel. Is that clear? Or opposite sides have to be equal. Is that understood? No, yes and no. See, try to understand. If I have a rectangle, right? Then I have a square. Then I have a rhombus. Now you know they all are parallelogram. Clear? So what is the common property of all these three? That opposite sides are equal, right? I'm not saying all the sides. I'm saying only opposite sides are equal. Is that understood? Yes? So this is the thing which is satisfying all the three figures. So therefore we can say they all are parallelogram. Is that clear? Yes? Please say yes and no. Okay, yes. Fine, Jocelyn. Right? So in quadrilateral ABCD, so first of all, we have to show it's a parallelogram. So we have to show that opposite sides are equal. So we take the opposite sides. That AB is equal to CD and BC is equal to AD, right? Opposite sides are equal. We are getting it, right? Because see here, like everything, every side is equal to every side. So we can say that AB is equal to CD also and BC is equal to AD also, right? So if opposite sides are equal, therefore quadrilateral ABCD is a parallelogram. Understand? Okay. Now if you have to show that it is a square, so what is the additional thing you have to show? That all sides are equal, right? Not just opposite, but all sides are equal. And that also we are getting. Also, AB is equal to BC is equal to CD is equal to AD. That means all sides are equal, right? Therefore, parallelogram. So it's already a parallelogram now we have shown. So the parallelogram ABCD is a square. No, no, no. We cannot say that it's a square because we have not shown the angle. Okay, wait. Yes, is my screen visible to all of you? I think it's visible now. See, I was getting AB is equal to BC is equal to CD is equal to AD, right? You can mark it some equation number 4 because we are going to use this result later on. So far we are saying that opposite sides are equal. So AB is equal to CD and BC is equal to AD, right? So opposite sides are equal, right? So therefore we can say that quadrilateral ABCD is a parallelogram. So first step, like the first result we have shown. Is that understood?
Yes, ma'am.
Okay. Now second, we have to show all the three sides are equal. That we have already shown. Sorry, all the four sides are equal. But still we cannot say it is a square. Now we have to show that one of the angle is 90°. Is that clear?
Yes, ma'am.
Okay. Now to show one of the angle 90°, you take triangles like this triangle, you take ABC, clear? And this triangle you take BCD. Is that understood?
Yes, ma'am.
Okay. So in triangle ABC and triangle BC, DCB, you can say, right? DCB. Now what I can take, already given that the diagonals are equal. So I can say AC is equal to BD, which is given to me, right? Okay. And I have
AB.
just shown that AB is equal to CD, proved already. And BC side is common here. BC is equal to BC, as you can see, it is common, right? Okay. So the triangles are congruent. So triangle ABC is congruent to triangle DCB. And from CPCT, you can say angle B is equal to angle C. Can I say that?
Yes, ma'am.
Okay. Now at least equal I have got. Now I have to show them 180 degree each, sorry, 90 degree each. So if their sum is 180, so there's a theorem, isn't it? Okay, have you written so far up till here? Written?
Yes, ma'am.
Okay. Yeah, see it. Pay attention now. Angle B is equal to angle C. At least I have got. Now I have to show that they are 90 degree each. Now I have already shown ABCD is a parallelogram. So that means this side is parallel to this side, right? And BC is a transversal. Is that clear?
Yes, ma'am.
Or just forget it. We know that ABCD is a parallelogram, right? Already proved. So there's a theorem that adjacent angles of a parallelogram are supplementary. Is that clear? That we have learned, right? So if I take this angle and this angle, so they are adjacent angles like one after the other. So I can say that angle B plus angle C is equal to 180 degree, right? Now, so I can replace angle B plus angle B, I can write. Why? Because they are equal. So from 5, we have already shown they are equal. So twice of angle B is equal to 180 degree. So angle B is equal to 90 degree. So one of the corner angle is now 90 degree, right? So you can mark it result number 6. Now you combine all the 3 results. First of all, it's a parallelogram. Then your result number 4, that all the sides are equal. And your result number 6, that one of the corner angle is equal, right? So from equation 4 and 6, we can say that parallelogram already proved. So parallelogram ABCD is a square with all the sides equal and one corner angle equal to 90 degree. See, Zeba, this question is not omitted, okay, because it is based upon properties of a parallelogram, right? Okay, Zeba, will you do one thing? The picture you have sent me, another condition for a quadrilateral to be a parallelogram, 8.5, right? Please send me a picture of this page 145 of your book. I just want to know which condition exactly.